Hello friends, welcome to Learner's Planet. Friends, this is our first session for time and work. In this session, we'll be discussing the basics of time and work and pipes and cisterns. Friends, I would recommend you to attend the sessions of percentage and ratio and proportion prior to this session. So you'll be comfortable in this session since we'll be using some of the concepts directly from these topics. Okay, let's begin the journey of time and work now. And I'm sure you are having your paper and pen with you. So let's begin. Friends, we use the terms time and work in our day-to-day life. Suppose I say I'll finish this work in 5 days, yeah, or I'll finish this novel in 10 days, or maybe I finish this product in say 7 days. Okay, but we are not considering the mathematics behind these sentences. Okay, so precisely we are not aware of the mathematics. Okay, suppose I tell I'll finish this work in say 10 days. So in one day, what amount of the work I will be able to finish? That is 1/10. Suppose I am able to finish a work in 2 days, then in one day I'll be doing the half of the work on an average. Okay, so let's see the concepts of the topic. Now, the very first point is if A can do a piece of work in X days, then the part of the work done by him in one day is 1 upon X part of the total work. Suppose I can finish a novel in 3 days. That means every day I'll be completing 1/3 of the novel. Or if I say I can finish a certain work in 2 days. Okay, that means every day I'll be doing half of the work. Similarly, if I can finish any work in 10 days, that means 1/10 of the work I can do in one day. So on an average, we have to find out a single day or unit work. Okay. Let's see the next point. Now, if A's one day's work is 1 by X part of the work, then the time taken by A to finish the work in is X days. Let's take an example. Arun can finish a piece of work by himself in 25 days. Then calculate the amount of work done by him in 16 days. If Arun can finish a piece of work in 25 days, that means every day he is doing on an average 1 by 25th of the total work. So per day he is doing 1/25th of the work. In 2 days he'll be doing 2 by 25 of the work. In 3 days he'll be completing 3 by 25 of the work. So in 16 days he'll be completing 16 by 25th of the work. Okay. Now let's come to the next point. If A is twice as good a workman as B, then A will take half the time B takes to finish a piece of work. Suppose I'm a good reader and I can finish a novel in 3 days. So me 3 days. And suppose B, a person, he is less efficient than me, or his efficiency of reading a novel is half than that of me, then definitely he'll be taking 6 days to complete the novel. Or if I take the other example, A can do a work in 12 days. Okay, and B is more efficient than A, or in other words, I can say B is double efficient than A. B is double efficient than A. Then in that case, if A is taking 12 days, B will be taking 6 days to complete the work, isn't it? So precisely, if I'm double efficient than you, then I'll be taking half the time which you are taking. And if I'm 3 times efficient than you, then I'll be taking 1/3 of the time which you are taking. Okay. Or in other words, or for any fraction, if we say if my efficiency is x by y times that of you, then I'll be taking y by x time than that of u. That means efficiency is inversely proportional to the time taken. The more efficient person will take less time, and the less efficient person will take more time to finish a particular task. Okay, let's take one example. Now, Suresh can finish a piece of work by himself in 48 days. Naresh, who is one-fifth the time more efficient than Suresh, he should complete the work by working all by himself in 40 days. Now, let's try to elaborate it. If Suresh can finish a piece of work in 48 days, that means per day he'll be working 1 by 48 of the total work. Okay, so his per day efficiency is 1 by 48. Okay, now Naresh is one-fifth the time more efficient. So suppose I consider the efficiency of Suresh as 1, and Naresh is one-fifth more. That means the efficiency of Naresh is 6 by 5. And we have already discussed the efficiency is inversely proportional to the time taken. The more efficient person will take less time to complete the work. Or the double efficient person will take half the time, the triple efficient person will take one-third of the time. Similarly, the 6 by 5th efficient person will take 5 by 6 of the time. Okay, so 5 by 6 of the time, which is 5 by 6 of 48. That means 40 days. So the person who is 6 by time efficient will take 5 by 6 of the time, and 5 by 6 of 48 is 40 days. That means Naresh will be taking 40 days to complete the same task which Suresh is doing in 48 days. Okay, I hope you are clear. Now, work can be measured by many units. Some of them are man days, man hours, man minutes, machine hours, etc. Suppose I take 5 days to complete a work. That means one single person is taking 5 days to complete a work. That means the work is of 5 man days. Okay, or if two persons are taking 7 days to complete the work, that means there are total 2 into 7, 14 man days work. Man days means the capacity of one person to accomplish the task. If two persons are taking 7 days, that means one person will take 14 days to finish the work. So similarly, we can calculate for man hours and man minutes. If one person is taking 5 hours to complete a task, that means the work is of 5 man hours. Or if two persons are taking 10 hours to complete the task, that means the work is of 2 into 10, 20 man hours. Okay. Similarly, if a machine is taking 5 hours to produce a particular article, that means the capacity of machine is 5 hours, or we can say 5 machine hours. Okay. We'll be applying the concept of man days, man hours, machine hours when we'll be discussing the problems. Okay, friends. Let's see the next point. Now, if A and B, while working alone, can do a piece of work in X and Y days respectively, then they will together take XY over X plus Y days to complete the work. Friends, let's try to derive this, how it is coming. A is taking X days to finish the work. That means per day A will be doing 1 upon X of the total work. Okay. And B is taking Y days to finish that work while working all alone. That means per day will be taking B will be doing 1 Y of the total work. That means per day 1 upon x plus 1 of the y, 1 by y of the total work will be done, which is actually x plus y over xy of the total work. So per day work is x plus y by xy. That means to complete the work, they will be taking xy by x plus y days. Okay, that means per day, if they are doing 1/3 of the work, that means they will be taking 3 days to complete the work. So 1/3 and 3. Okay, so x plus y by xy is also having the same relationship as these two. Okay, so per day, if they are able to finish x plus y by xy work, then they will be taking xy by x plus y days to finish that particular work. Okay, now let's understand this concept with the help of this particular example. Here, A can finish the piece of work by working alone in 18 days. B, while working alone, can finish the same work in 24 days. If both of them work together, then in how many days the work will be finished? Here, we can see that A can finish the work in 18 days and B can do the same work in 24 days. That means B is less efficient than A. But both of them are working together. That means definitely the number of days should be less than 18. Okay. Now how do we calculate the number of days? Let's do it. Now A can do the entire work in 18 days. That means in a single day he'll be doing 1 upon 18th of the work. Okay. Similarly, B is able to complete the entire task in 24 days. That means in a single day he will be doing 1 upon 24 of the work. Okay. Now A is doing 1 upon 18th of the work and B is doing 1 upon 24th of the work per day. So in a single day, if both of them are working, this much work will be done. Okay. So in a single day, 7 over 72 work will be done. Okay, that means the entire work will be finished in 72 by 7 days. That is something around 10 days. Okay, 10 point something. I hope you are clear. Now let's discuss the concept of pipes and cisterns. Here, work done is in terms of filling or emptying a cistern, and the time taken is the time taken by a pipe or a leak to fill or empty a cistern respectively. Generally, time taken is to fill a cistern is taken as positive. A pipe connected with a cistern is called an inlet pipe or an outlet pipe according as it fills or empties the cistern respectively. The basic concepts related to time and work and pipes and cisterns are quite similar. In both the cases, some work is going on. In the case of time and work, the work done is always positive. That means the work is going to be done. But in this case, there is some negative factors also, as if one pipe is filling the tank and the other pipe is emptying the tank. So work is getting done also, and the work is negative also. Okay, so there is bit difference in the concept. Okay, suppose I assume one pipe. We understand this concept with this practical example. See, here it's an inlet pipe and here it is an outlet pipe, and this is a tank. Now this inlet pipe is filling the water in the tank and this outlet pipe is emptying the water from the tank. Now the work is done positively by this pipe and the work is done negatively by this pipe. That means there is a positive work, there is a negative work. Now suppose I assume the capacity of this particular pipe is X hours to fill up the tank, and the capacity of this particular pipe is Y hours, and Y hours is what? Like it can empty the entire tank, that means the complete filled up tank in Y hours. Okay, so just listen to me very carefully. This pipe can fill the empty tank in X hours, and this pipe can empty the filled up tank in Y hours. Okay, now we started both the taps or both the pipes simultaneously. Now it is filling the tank and it is emptying the tank. Okay, now what would happen? X may be anything, Y may be anything. Maybe X is more, Y is less, or maybe X is less, Y is more. Now we have chosen the variables over here. Now if this particular pipe is able to fill up the tank in X hours, that means in 1 hour it will be filling 1 upon X part of the tank, right? Similarly, this pipe is able to empty the tank in Y hours, that means in 1 hour it will be emptying 1 upon Y uh, part of the tank. Okay, now this is a positive work and this is a negative work. So this pipe is filling the tank and this pipe is emptying the tank, and this is a negative work, so I'll be just putting a negative sign over here. Now what would happen? It's y minus x over xy. So in 1 hour, this much portion of the tank will be filled up or emptied, isn't it? It depends upon the value of x and y. I assume x to be maybe is 3 hours and y I assume to be 4 hours. Okay, that means this pipe can fill the tank in 3 hours and this pipe can empty the filled up tank, that the complete tank, in 4 hours. Now what would happen over here? In 1 hour this pipe will fill up 1/3 of the tank and this pipe will empty 1/4 of the tank per hour. Since it is the negative work done by this pipe, I'll put a minus sign over here. So it's 4 minus 3 over 12, 1 upon 12. That means in every hour 1 upon 12th part of the tank will be filled up if both the pipes are running simultaneously or we have started them simultaneously. Okay, getting my point? Now what is happening? Per hour 1 upon 12th part is filled up. So in all 12 hours it will take to fill up the tank completely. Okay, so this is an easy concept, but we have to be careful about the negative work done by the other pipes. Okay, similarly there can be a leak also, there can be taps also, various things are possible, but the basic concept will remain same. Okay friends, I will speak about time and work or pipes and cistern cases. The various types of problems are there. So, and for every pattern of problem there is a formula, but I do not recommend to mug up the formula at all. Why? Because in the examination time you cannot recall the formula, like which formula to put in which place. Okay, so what I suggest you to understand the concept of negative work, positive work. That would be rather better than mugging up the formula. Okay, I just can show you all these formulae. If an inlet pipe can fill a cistern in X hours, then the part filled in 1 hour is 1 by X. That the concept we have already discussed. Similarly, if an inlet pipe can fill a tank in X hours and an outlet empties a full tank in Y hours, then the net part filled in 1 hours when both the pipes are opened is 1 upon X minus 1 upon Y. Okay. Similarly, if both the pipes are working in the same direction, that means from both the pipes the positive work is getting done, then there will be 1 upon X plus 1 upon Y part of the tank will be filled up in 1 hour. So this is the case like this. If there are more than 2 pipes, say in this case, and all of them are working in the same direction, that means all of them are filling the pipe, then this will be the situation. That means per hour, that's 1 upon X plus 1 upon Y plus 1 upon Z part of the tank will be filled up. Okay, now there may be a case when the 2 pipes are filling the tank and the third one is emptying the tank, then the work done by the two pipes will be positive and the work done by the third pipe will be negative. So in that case, the first pipe is filling 1 upon X part of the tank, the second one is filling 1 upon Y part of the tank per hour, and the third one is emptying. So since it is emptying, I'm putting up a negative sign over here that shows the negative work done. Suppose it is 1 by Z. Okay, now that means the third pipe is taking Z has to uh, empty the completely filled up tank. So the two pipes are working positively in the positive direction, or the third pipe is negative work. Okay, so this may be a case. Okay, so you have to be conceptually clear about it. Okay, now let's take some examples. Now let's see this question. Amulya alone does a piece of work in 2 days and Bindu does it in 6 days. In how many days will the two do it together? A very simple concept of time and work. Okay. Now Amulya is doing the work in 2 days. That means in a single day or in one day, he will be doing half of the work. Similarly, Bindu is taking 6 days to finish up the work. That means in a single day, she'll be doing 1 upon 6 of the work. Now, half of the work every day is being done by Amulya, and 1/6 of the work every day is being done by Bindu. So, if both of them are working together, this much work will be done per day. That is 2 by 3. So per day 2 by 3 work will be done. Okay, so definitely how many days will it take to get the work completed? It is 3 by 2 days. Okay, so it's quite simple problem. Friends, I would finish this particular session over here only. We will be taking more examples and problems in the next session, but I would recommend you just have a quick recap of this session before coming to the next session. Okay, I'm sure you will find it very easy and interesting topic. Okay, bye bye.